Everyone, we have finally made it to the BC content or BC topics. So our first BC, well really our second BC topic, because we already did Euler's method, is called integration by parts. And it's a way to integrate a product, and it basically comes from product rule for derivatives. So let's start by reviewing product rule. Remember, we learned product rule as the derivative of f of x times g of x would equal f of x times g prime of x plus g of x times f prime. And then remember, the easy way to remember was just first times derivative of the second plus second times derivative of the first. Okay, we're going to use that same rule, but instead of using f of x and g of x, we're going to find the derivative of u times v. Typically, integration by parts formula is written in terms of u and v, but I do want to show you that it really is just product rule. So we're finding the derivative of u times v. We would end up with u times the derivative of v, which I'm just going to call dv, plus v times the derivative of u, which I'm going to call du. Okay, now let's say we've got our derivative, but we want to integrate this product rule. So we're going to integrate both sides. So I'm just going to integrate both sides of this equation. Well, on the left side, if I'm finding the integral of the derivative, those are just going to undo each other. So the left side is just going to equal u times v. Okay, on the right side, I'm going to use my properties of integrals, and I'm going to break up this sum and make it the integral of u times dv plus the integral of v times du. Okay, so the product that we want to solve for is the integral of u times dv. So to solve and get that by itself, I'm going to subtract the integral of v times du on both sides. And we basically end up with the integration by parts formula, which says that this, the integral of u times dv, is equal to u times v minus the integral of v times du. And this is basically integration by parts. And again, it just comes from product rule. Okay, so again, this is our formula. If u and v are functions of x and have continuous derivatives, then the integral of u dv is equal to uv minus the integral of v du. Okay, now, what does an actual problem look like? We'll look at example 1. We want to find the integral of x times cosine of x. So this is what we're given. Like, this represents the integral of u dv. So the first thing that you have to do is, when you look at your integrand, you know, we're multiplying two functions, x times cosine of x. We have to figure out which function do we want to set equal to u, and which function do we want to set equal to dv. Okay, so here are some guidelines to help you figure that out. You want to try letting dv be the most complicated portion of the integrand that fits a basic integration rule. And then let u be the remaining factor of the integrand, or I would say let u be the easier portion of the integrand. So, I mean, if we're looking at x times cosine of x, x is the easier portion, and I would say cosine of x is the more complicated portion. Okay, another way to think of it is try letting u be the portion of the integrand whose derivative is a function simpler than u, and then dv will be the remaining factor of the integrand. So In that case, if we let u equal x, the derivative of u is just equal to 1. You know, and that's simpler than what we started with, okay? All right, once you figure out what u equals and what dv equals, then whatever u equals, you're going to derive it, you're going to find the derivative, so we're going to find du, which would equal 1 times dx. Whatever you set dv equal to, we're going to integrate, okay? So if we integrate dv, we end up with v. That's going to equal the integral of cosine, which is sine. Okay, now you might be asking, wait, why isn't she adding the plus c? We will add the plus c eventually, okay? But we're just going to hold on for right now. Okay, so once you've got that all figured out, then you're just going to plug into the formula, okay? So the integral of x times cosine of x would equal, I'm just going to separate that, it'll work, u, which is x, times v, which is sine of x, minus the integral of v, which is sine of x, times du. Now du is 1 times dx. So sine times 1 is sine, and then we just need to also add the dx. Okay, so we're not quite finished though because we still have an integral in our problem. So you want to keep going until you don't have an integral anymore. But we really only have one more step. We're going to break down the x times sine of x, but then minus, now we have to solve this integral. So remember, the antiderivative of sine of x is negative cosine of x, so that's going to change this minus to a plus. And then we'll add the plus c. And that is our final answer to this problem. So that is the integral of x times cosine of x using integration by parts. Okay, now that you've got the overall idea, let's look at a few, different scenarios that can happen. Well, actually, before we get to that, this is a little bit more help with you figuring out what to set u equal to and what to set dv equal to. So if you have an integral in any of these forms where you have like x to the n times an exponential function or x to the n times a trig function, then you want to let u equal x to the n and let dv equal the exponential or trig function. If you are faced with x to the n times natural log or x to the n times an inverse trig function, you actually want to reverse that. You want to set u equal to natural log for the inverse trig function and let dv equal x to the n. Okay, if you are dealing with integrals that have exponential and trig, you want to let u equal the trig function and let dv equal the exponential function. Okay, so these are some guidelines that can help you out to make this a little bit easier. Okay, now let's look at some scenarios that can come up. So when you first look at this integral, it's the integral of 4x divided by e to the x. So you might be wondering, well, wait, that's not a product. Why are we using integration by parts? But we could rewrite the integrand into a product. So I would first rewrite this as the integral of 4x times e to the negative x power. So just using our properties of exponents, we can rewrite the integrand. And so now you can use integration by parts. Okay, so again, we've got to figure out u, and we've got to figure out dv. So if you go back to the guidelines, this is what we're dealing with. So we're going to let u equal the x to the n, and let dv equal the exponential function. Okay. So u is going to equal 4x, and dv is going to equal e to the negative x power times dx. Okay, this is like your u here, and then your dv. Okay. All right, so then you find the derivative of u, So du is going to equal 4 times dx. And then we're going to integrate dv so we can find v. So if we integrate e to the negative x, that's going to be e to the negative x divided by negative 1. So we'll end up throwing a negative out front. Okay, we're ready to plug into our integration by parts. So this is going to equal u 4x. You know what? I'm going to bring it down so I have plenty of room. So we're saying that the integral of 4x times e to the negative x dx is going to equal u, which is 4x, times v, which is negative e to the negative x. I'm just going to put the negative in front of 4x, minus the integral of v times du. Okay, now we can clean this up a little bit. So negative 4x times e to the negative x. First of all, subtracting a negative is going to become addition. And I'd probably put the 4 in front of the exponential function. And actually, we could even move it out as a constant multiple. So that might be easier when we have to integrate. And then remember, you don't want to leave any integrals in your answer. So we've got to integrate the e to the negative x, which is going to end up being e to the negative x times negative 1. I'll just put times negative 1. Okay, and then we'll finally add the plus c. And then to just kind of clean this up, my final answer is negative 4x times e to the negative x minus, because I'm multiplying the 4 times the negative 1, 4 times e to the negative x plus c. Whew, and we are done. Yeah, I would stop right there. The answers that you get here aren't the prettiest, I would say, but they are correct, so that's a good thing. All right, moving on. Sometimes you will end up having to integrate more than one time. So in the previous 2 examples, after we plugged into integration by parts, we only had to integrate one time to get rid of the integral. Sometimes you have to do it more than once. So let me show you how that works here. All right, so again, we're going to start with, and if you go back to your guidelines, because these can be really helpful, we are dealing with this type of integral, or you can think of because it's cosine. So again, we're going to set u equal to x to the n and dv equal to the trig function. So u is going to equal x squared, and dv is going to equal cosine of x dx. Okay, then you always find the derivative of u. We're going to get 2x dx. And then you always integrate the dv to find v. So the integral of cosine is sine. And then you plug into your integration by parts formula. Okay, so we're saying that the integral, this is just the original problem, is equal to u, which is x squared, times v, which is sine of x, minus the integral of v, which is sine of x, times du. Now, because du is 2x dx, I'm going to put the 2x in front of sine of x and rewrite it like this. Okay, now we've got to evaluate this integral, but are you noticing anything? We have to use integration by parts again. Okay. All right, so let's do that. So maybe I'll use a different color. Okay, so this is just to integrate the 2x times sine of x dx. Okay. All right, we're going to set u equal to 2x. We're going to set dv equal to sine of x dx. We're going to find the derivative of u, which equals 2 times dx, and then we're going to integrate dv to get v. The integral of sine is negative cosine. Okay, we're going to use integration by parts again. So I'm going to bring this down. Ooh, that's a bad curly brace. Okay, I'm going to give myself some more room. These answers can get pretty long, you're probably noticing. So I'm just going to bring down the x squared sine of x. I'm going to go back to red. Okay, minus, and now I'm going to use my integration by parts again for this. So that integral is going to be, and because you're subtracting, I would put it in parentheses, because we're going to have to distribute that negative. But let's just go through integration by parts. So it's u, which is 2x, times v, which is negative cosine, minus the integral of v, which is negative cosine, so I'm going to make that a plus, times du, which is 2vx. So I'm going to put the 2 out front as a constant multiple. Okay, we're getting there. All right, let's distribute our negative. So we'll end up with plus 2x times cosine of x. Okay, plus 2 times the integral of cosine of x dx. And then, sorry, I was distributing a negative, minus 2, because I'm distributing that negative. Okay, and then we have to integrate cosine of x, but we'll be done after that. Okay, so x squared times sine of x plus 2x cosine of x minus 2 times the integral of cosine, which is sine, and we'll finally add the plus c, and that is our final answer. And remember, that was the final answer to this integral. Okay, it just took a few steps to get there. So sometimes you do have to use integration by parts more than one time. Okay, and this was a good example. Okay, one last example. Sometimes you might find yourself going in a circle, and like you find where you just have to keep integrating and integrating and integrating, and like that integral is never going away. So there is a way that you can handle that sort of problem, and the idea is you keep integrating until you get back to your original integral, which is the integral of e to the x cosine of x, and that's why you're going in a circle. But anyway, let me show you how it works. Okay, so again, we're going to start with our u and our dv. So because we're dealing with exponential and a trig function, you know, if you go back again to your guidelines, we're dealing basically with an integral of an exponential function and a trig function. So we actually want to set u equal to the trig function and set dv equal to the exponential function. Okay, so we're going to set u equal to cosine, and we're going to set dv equal to e to the x. We're going to find the derivative of u. Derivative of cosine is negative sine dx. And then we're going to integrate dv to find v, and the integral of e to the x is just e to the x. And then we're going to set up our integration by parts. So I'm going to bring down my original problem. So this would equal u, which is cosine, times v, which is e to the x. I'm just going to put that in front. Minus the integral of v, which is e to the x, times du, which is negative sine of x dx. So because of the negative, I can make this a positive, and then I'll have times sine of x dx. Okay, so we're going to integrate, but notice we have to use integration by parts again, so I'm actually going to hold off on that. Okay, so we're going to have to do integration by parts with the e to the x sine of x. But we're going to do the same thing like we did previously. We're going to set u equal to sine, and dv is equal to e to the x dx. We're going to find the derivative of u, so derivative of sine is cosine, then we're going to integrate dv, and we're going to get v equals e to the x. You can kind of see why this one is going to end up in a circle. Okay, we're going to do integration by parts again. So, let me scroll down. Okay, so you guys, I'm going to bring this, well actually I'm going to bring all of this down. Okay, so our original integral, and we know that equals d to the x times cosine of x. Okay, plus, and then we're going to do integration by parts again. So we're going to do u, which is sine of x, times v, which is e to the x, minus the integral of v, which is e to the x, times du, and I keep forgetting my dx. Okay, so du is cosine of x times dx, so cosine of x dx. And see, if you notice, we're stuck where we'd have to do integration by parts a third time because we still have this product, e to the x times cosine of x. But notice it's the same as what we started with. So that's when you know you can stop, okay? And we're going to proceed like this. We have this equation, right? I am going to, because I'm back at my original integrand, I'm going to add this integral to both sides of my equation. So here, because I have a positive and a negative of the same thing, they're going to cancel. But over here, it's like combining like terms. I have one integral of e to the x cosine x plus 1. So that's going to end up equaling 2 times the integral of e to the x cosine of x. It's like putting a number in front. So I'm just adding the 1 plus 1 to get 2. Okay, and we know that that is equal to e to the x times cosine of x plus e to the x times sine of x. And then I'm going to solve for my integral here, because that's what I was originally trying to solve for, by, you probably guessed it, dividing by 2. To undo that multiplication, I'm going to divide by 2, and then we're just going to add a plus c. And we have our final answer to the original integral. Okay, so again, the point of this example was if you find yourself going in a circle, like you just can't get rid of integration by parts, then you can stop as soon as you get back to your original integral, and then you just add that to the other side, and then you just divide to get it by itself. All right, you guys, I know that was a lot to take in. We'll definitely, practice this in class, but it would definitely be helpful if you know the integration by parts formula and, some of the guidelines that we've talked about. Okay, so maybe study your notes a little bit. And as always, thanks for watching. I'll see you tomorrow.